And welcome back to the morning show. It's Wise Guys Wednesday. Our wise guy, U of I physics professor Matt Sellon is here. And Matt's talking water pressure, water towers, and maybe we're going to make a mess.
Oh, well, yeah, you might get a little wet.
All right.
So that's okay. It's driving around between little towns in central Illinois. You see everyone has a water tower in every little town. And I thought it might be kind of cool to explain what the purpose of those things are. And to understand that, you have to understand how much water that we use.
Okay.
Do you know how much water we use, every single person, every day?
5 gallons.
No, it's probably more like about 50 to 100 gallons a person. If you average it out over, including laundry and stuff like that.
No wonder my water bill's so high.
Do you know where most of that goes?
Down the drain.
Flush.
Down the toilet.
Exactly. And, laundry and showers, all that stuff, it all adds up to quite a bit. And so in a community of maybe 4,000 or 5,000 people like Tuscola, where I live, you have, in one day, you may need 500,000 gallons of water for all the people to do their stuff. And so that's what's in that tank. That great big water tower contains all that water. Now, if you figure out how much water that is per minute, 500,000 gallons is about 350 gallons per minute. So that's a lot. And if you were the mayor of some town and you had to buy a pump to get water from the water treatment plant to people's houses, okay, you can get a pump that pumps 500 gallons a minute. That's not a big deal. But think about it. You don't use that water at 2 in the morning. You're not using 350 gallons a minute.
Right.
At 7 o'clock, 7:30 in the morning, when everybody goes up having a shower, flushing, all that stuff, you may be using 10 times that much.
Sure.
And so you would have to buy a pump that was 10 times bigger than you really needed on average, which would cost you way too much money.
Yeah, makes you wonder how it works.
Exactly. So what the water tower does, 2 important things. The main thing, one of 2 things it does is it acts like a reservoir. I scared you there, didn't I?
You did. I thought you were just going to turn it on me and give me a shower.
And it also provides pressure. Okay, and so what you do is you have enough water in a water tower to last you about a day. Even if the power goes out, in fact, when you have a power outage, you've never actually turned the water tap on and not had water in a town, right? Because the water is always in the water tower kind of waiting, and just gravity brings it down.
Sure.
So it's kind of reliable that way, plus it provides pressure. And if you've ever, here's how you understand the pressure. If you ever dive in a swimming pool and you go to the bottom, maybe 10 feet down, you feel the pressure in your ears, don't you? Right, and it's quite a lot of pressure for just 10 feet. It turns out that the amount of pressure you get from having water stand in a vertical column is about, let's see now, there's 30 feet is 15 pounds per square inch. So for every foot, you get about half a pound per square inch of pressure. Okay. Now, so right now, I've sort of made this phony water tower out of a piece of lucite. Notice that here's my exhaust hose. The level of the water in the exhaust hose is exactly equal to the level of the water at the top of the tank.
Right.
If I bring this thing down, okay, and now I have where the water comes out is significantly below the level of the water up there, it comes out pretty rapidly.
Right.
I'm trying not to make a big mess here.
That's
okay. Now imagine what you need, the kind of pressure of water you need to run appliances is maybe between 50 and 100 pounds per square inch, okay, to run your dishwasher, stuff like that. So what you need is you need to have a column of water maybe 100, 150 feet high. So that's why you see these water towers in little towns are pretty tall, because it gives you a lot of pressure that way. And that's actually a significant amount of pressure. And I'm going to do this without making a mess.
Don't worry about making a mess.
Okay. So you might want to stand back. If I bring this hose down, suppose you lived on a hill right next to a water tower, and you walked up that hill with a hose to water your flowers. If you walked up a hill as tall as a water tower, you couldn't do it. Nothing would come out.
Right.
As you bring the thing down, you got a lot of water coming out. Okay, I can squirt pretty far.
More pressure.
As I bring the thing up, I have less and less pressure. Ultimately, I have no pressure at all up here.
Right.
Okay, so at the bottom of the tower, you have an awful lot of pressure. You have probably at least 50 pounds per square inch, which is quite a bit. And it's enough that it's very hard for you to put your finger over the thing and keep the water from squirting out. Okay,
right.
So I mean, this is just a couple of feet, and it's I can really feel it like this with my hand.
You could spray it across the room. You could probably hit one of the cameras if you wanted to.
Oh, let's try it.
Go for it. Right there.
Okay.
You scared Dawn, our camera person.
So
she's not going to come back in the second segment if we keep doing that.
Right. So anyways, the function of towers is basically to provide pressure by just gravity pushing down.
Okay,
Just because water weighs a lot. A gallon of water weighs about 7-8 pounds.
Okay.
And so if you have it way up high, down below, you have just an awful lot of pressure. And when we come back, we'll talk a little more about pressure, and I'm also going to show people how, in their own little town, and we have pictures of water towers, you're going to be able to estimate how tall those water towers are. We're going to do a little math.
And one of them looks like a ketchup bottle. I've already seen it. It's pretty cool. All right, if you have questions for our wise guys, send them to the morning show at wcia.